LALR parsing. So LALR is nothing but look ahead LR. So in LALR1 parsing, the LR1 items which have same productions but different look ahead are combined to form a single set of items. So previously in CLR we have seen we are going to write the look ahead symbols there. So here what we will do in LALR, the difference between CLR and LALR is nothing but in CLR we are going to write all the look ahead symbols and all the states will be using in the data flow diagram as well as in the table also, in the parsing table also. Whereas in LR what we are going to do is the LR1 items which are having same productions but different look ahead symbols. If we have same productions but different look ahead symbols, those will be combined into a single set of items. So if we see the example, you will understand clearly. So LALR1 parsing is same as CLR1 parsing, only the difference is in the parsing table. Okay. CLR will have states and in LALR states will be reduced by merging and replacing the states with same look ahead values. So consider here an example grammar: S tends to A tends to AA and A tends to B. So the same steps we need to follow here. First step is write the augmented production. So augmented production is introduce a new symbol related to the starting symbol, that is S dash tends to S. And the second step is write the canonical collection of LR1 items and look ahead items. So here write the canonical collection, that is S dash tends to dot S, and this given grammar you need to write, that is S tends to dot A tends to dot AA and A tends to dot B. Along with this you need to write the look ahead symbols. How to calculate these look ahead symbols I have already explained you in CLR parsing. Just have a look there. And here I already said you the difference will be in the parsing table. So we'll write here how we'll write the reduce operation. So for reduce operation, whatever the productions we take, for that you need to assign the numbers. So we need to remove the augmented production. For that reduce we will not be using in augmented production. So remaining S tends to A tends to AA and A tends to B, this we are assigning number respectively as 1 2 3, and this we are writing as reduce 1, reduce 2 and reduce 3. And so here now we need to draw the data flow diagram. So data flow diagram, so first S dash tends to dot S dash S tends to AA, A tends to AA and A tends to B. Along with this look ahead symbols I have written here, and this I am considering as state I naught. So now you need to perform until this dot is placed to the last of this production. So I naught on symbol S. So we do this transformations after on this right hand side symbols, whatever we have on this we need to do the transformations. So I naught on symbol S. So I naught on symbol S. So what, how it becomes? It becomes as S dash tends to, this dot will be shifted here. That means S dash tends to S dot. Along with this the look ahead symbol you need to write, that is dollar. And next I naught on state capital A. So what it becomes? S tends to, this dot will be shifted here, that is A dot A, and the look ahead symbol dollar. So after dot we have a non-terminal. After dot if we have a non-terminal, we need to write all the productions of that non-terminal. So the productions of that non-terminal are A tends to dot AA and A tends to dot B. So that you need to write A tends to dot A and A tends to dot B. So the look ahead symbol we need to write whatever the look ahead symbol we have in this existing state, this I2 state. We are considering this as state I2. So in I2 we have this look ahead symbol as dollar. This look ahead symbol only you need to consider here. Next this production, so on symbol small a, so on symbol small a it will be changing as A tends to, this dot will be shifted here. So then it becomes as A tends to A dot capital A comma, the look ahead symbol is A by B, that you need to write here. And here after dot we have a non-terminal. So write all the productions of that non-terminal, that is A tends to dot AA A tends to dot B, and the look ahead symbol what we have here, the same look ahead symbols you need to write here. And next, A tends to dot B, so this has been shifted here, that is I naught on symbol B, it will be done as A tends to B dot comma look ahead symbol A by B. This I am naming as state I4. Okay. And next, I5. So here this I not state has been completely done. So now we should check these all states. So I1 state, there is no need to do anything here. Next, coming to I2 state, so the dot should be shifted here. So for that, on symbol A, if we perform these transformations, that is I2 on A, so it becomes as S tends to A dot comma the look ahead symbol dollar. So this I am naming as state I5. And next, I2 on symbol small a, so I2 on symbol small a, it becomes as A tends to A dot A. So A tends to A dot A is already there in this state I36. So directly I am drawing a transformation here. Okay. And next, A tends to dot B. So A tends to dot B, it becomes as A tends to B dot. So it is already there in state I47. So directly I am drawing a transformation there. And next, coming to this state, so A tends to A dot A, so it becomes as A tends to A dot. So A dot, so A tends to A dot, A tends to A dot, and this look ahead symbol A by B. So this I am naming as state I89. And next, A tends to this on small a, if we perform, it becomes as A tends to A dot A. So it is already there in the same state, so I am drawing a self loop here. Next, A tends to dot B, so it becomes as A tends to B dot. It is there in I47, so I am drawing a loop over there. I'm drawing a transition over there. So this is how we do the data flow diagram, and then you need to draw the parsing table. Need to draw the parsing table. So parsing table is same as how we draw for CLR. So here you need to write states, actions, and go to. In actions you need to write terminals, in go to we need to write non-terminals, and in states, whatever the states we have, that you need to write. So we have the states here as I0, I1, I2, I36, I47, I5, and I89. So that states I have written here. Now from this data flow diagram, you need to fill this parsing table. I0 on small a. So I0 on small a, it is moving to state I36. So we need to write here shift 36, that is S36. I0 on small b. I0 on small b, it is moving to state I47. So we need to write as shift 47. I0 on dollar. I0 on dollar, it is not there anything. So I0 on capital S. I0 on capital S, it is moving to state I1. So just you need to write the number here 1. And I0 on capital A. I0 on capital A, it is moving to state I2. So we need to write the number 2 here. Next, I2 on small a. State I2 on small a, it is not moving anywhere. On small b, it is not moving anywhere. On capital A, it is moving to state I5. So on capital A, next to I1 on state I1. So I1 on state A, it is not moving anywhere. So I1 on dollar, we need to write as accept. It is mandatory. I1 on dollar, symbol dollar, you need to write accept. So next, I2. So I2, state I2 on symbol small a. I2 on symbol small a, it is moving to state I36. So I2 on symbol small a, it is moving to state I2 on symbols, it is moving to state 36. Next, I2 on small b. I2 on small b, it is moving to state I47. So you need to write here as S47. Next, I2 on capital A. I2 on capital A, it is moving to state I5. So just write the number 5 here. Next, I36. I36. So I36 on small a, it is moving in the self loop, that you need to write S36. I36 on small b, it is moving to I47, so write S47. Next I36 on capital A. I36 on capital A, it is moving to I89, so write here I89. Next I47. So check I47. So I47 state here, it is not moving to any other state, so we need to write here reduce. So how we need to write reduce here? What is the production we have? A tends to B dot. So A tends to B, what we have written here? R3. So R3 we need to write. Where we need to write the R3? Only in this look ahead symbols. In A and B, in state I47, in place of A, B, we need to write R3. And the next one is I5. So I5, in state I5, it is not moving to any other state. So what is this? S tends to AA. So S tends to AA we have written as R1. So R1 we need to write in this look ahead symbol. So R1, I5 on state dollar, you need to write R1. Next I89, it is also not moving anywhere, so the production is A tends to AA, so it is written as reduce to. Reduce to you need to write in the look ahead symbols A and B. So reduce to is written in the symbols look ahead A and B. Okay, this is how we construct the LALR parsing table, and you need to parse the input string. From this table, you need to parse the input string. So consider the input string as AA, and we need to consider stack, input and action. So in stack, we are going to first insert the dollar. So input, write the given input string AA, and in stack, first as we are starting our states from 0, first we are starting from 0 here. So place 0 in the stack. Now 0 on small a. So 0 on small a. What it is there? Shift 36. So you need to shift. What is the action we need to do here? Shift. What you need to shift here? From this input we need to shift one symbol. So shift. This symbol you need to shift here, that is A. So this symbol you need to shift here, that symbol A36. The number here is 36. So you need to write shift A36. So A36 will be shifted here. So it becomes as $0 A36. And the remaining input is what? A dollar. After input you need to place dollar. It is mandatory. Next. Now you need to check now. 36 on small a. Check here, 36 on small a, we have shift 36. So you need to write here shift. What we are shifting here? One symbol, that symbol is A36. So A36 should be shifted here. Then the stack will become as $0 A36. Till here it is there, and A36. And now check what is the action to be performed. 36 on small b. 36 on small b, we have here S47, that is shift 47. So you need to write shift 47. What we are shifting here? The symbol B. So I have written here shift B47. So this B47 should be shifted into this stack. Now write what action should be performed. Check 47 on small b. So 47 on small b. What we have here? Reduce 3. So what is reduce 3 here? Reduce R3. R3, in R3 the grammar is A tends to B. So in place of B you need to write this capital A. So in place of this B I am replacing it with capital A. Then this number also we need to change. No? So how we can change the number? Check this previous number with this non-terminal. So 36 on capital A. 36 on capital A. We have 89. So 89 you need to write here. Now 89 on small b. 89 on small b. We have reduced to. So write reduce to. Reduce to is A tends to AA. In place of small a capital A you need to write A. So in place of this small a and capital A I have replaced it with capital A, and the number how we need to write here, check this previous and this one. 36 on capital A. 36 on capital A, we have 89. So write 89 here. Now 89 on B. So check 89 on B. We have R2. So 89 on B, we have R2. Write reduce R2, A tends to AA. Okay. Now in place of AA, we need to substitute it with capital A. So this A and A are being reduced with capital A. So the number you need to write 0 on A. Check 0 on A. 2 we have here. So write number 2 here. Now 2 on small b. 2 on small b. We have S47. Shift 47. So write here shift. What we are shifting here, the symbol we are shifting here is B. So write shift B47. So B47 is been shifted here. Now 47 on dollar. 47 on dollar. We have reduce R3. So R3, reduce R3. R3 production is A tends to B. So A tends to B, in place of B you need to substitute it with capital A. So in place of B we are substituting with capital A. Now the number we need to write now 2 on A. So 2 on A, we have 5. So write 5 here. Now 5 on dollar. 5 on dollar. So 5 on dollar we have 5 on dollar we have reduce R1. So right here reduce R1, the production is S tends to AA. So in place of this AA we need to substitute it with S. So the number to write is 0 on S. 0 on S. 1. So the number you need to write here as 1. Now check 1 on dollar. So 1 on dollar. 1 on dollar what we have? Accept. So 1 on dollar is accept. So finally our LALR, the string is been accepted, and then you need to draw the parse tree. So you know how to draw the parse tree. Based on the given input string you need to parse the parse tree. So this is all about LALR parsing.